I can introduce now our final speaker today, and his presentation is on recent developments in the field of user-friendly testing of mechanical and comfort properties of textile fabrics and garments. And this is Professor Lubos Hes, who is Professor of Textiles and Department Head at the Technical University of Liberec. He's lectured, and that's in the Czech Republic. He's lectured several years in Portugal, also in Taiwan and Germany. He's the author of 6 commercialized instruments for comfort measurements, and also the author of 45 patents on textile instruments and machines. His interests are in clothing comfort, hence the paper, energy conservation, and also yarn texturizing. I can hand over to Professor Hes.
Thank you, Coach. Good afternoon, ladies and gentlemen. I'm glad to be again in Egypt, that marvelous country. I'm really grateful to the organizer. My presentation is very simple. I use quite simple pictures because the topic is also quite simple. Anyway, I think it's quite important today because comfort, as Professor Lubos mentioned in his excellent presentation, is something natural. This is a natural part of marketing, natural part of business. And our philosophy is to bring measuring methods, measuring instruments into shops, into big shopping centers, to show to clients why they pay high added value for special products. I mean alpinist products, protective clothing, anything which is better than the average could be measured, should be measured, and it is, if possible, that values should be somehow explained to the clients why they pay so much money. You know, a common t-shirt costs $2. High-tech polypropylene t-shirt manufactured in Czech Republic costs $10. That's quite big difference. So that's the reason, but we should show to our clients why they pay $8 more. And we hope to have some techniques to convince the clients why they should pay. But first we should have simple and fastest methods, and we should introduce instruments which evaluate not simple individual parameters, but some complex parameters. Something which concentrates, integrates several parameters. We also want to introduce systems which are fast and friendly. Automatic testing, for example, and systems which evaluate several parameters in one step, like a fantastic instrument by George Stilias. There are some other instruments which are under development or which are, let's say, commercialized. So that is this is the content of the paper, and the current market requirements. This is something which I have already mentioned. Well, we should concentrate on high added value products, and such products cannot be developed, optimized, offered without measurement. The problem is that instruments which are on market today, in fact, not always fulfill the demands I have in mind, or which is generally available. Instruments should be so simple that technicians and people without special education should be able to operate them. For practical purposes, one-point measurement, it means no curves like Kawabata offers, just final point measurements, in my opinion, offers enough information concerning the comfort parameter. A very important point is specimen production. Making specimens, cutting specimens is always very costly. even 20 for 20 centimeters cut from costly fabric is a lot of money because you spoil the full width of the fabric. Imagine that you have 2 meters of large and you cut 20 centimeters, so that's a lot of money. So we should suggest such a method which should avoid the damage, destruction of the sample. And the final point is a very important one. It was found and proved that transient parameters are a very important component of comfort characteristics, because in fact we are not steady objects. Just when sleeping, when laying in coffin, it's quite a really steady state situation, but since so long we are alive, we move, we make dynamical effects, we make ventilation effects. So transient parameters are very important part of comfort evaluation. So classical instruments, as you can read, are sometimes very costly, sometimes not easy to operate, sometimes too complicated, sometimes the specimens are necessary, and sometimes they measure just steady-state characteristics, which should be avoided. Well, that's why friendly testing as a term was introduced. Such a friendly testing means that the method is simple, easy to understand. The measurement involves several parameters, as I already mentioned. Measurement is fast, and results are at best supplied by some automated procedure. As already mentioned, avoiding of space cutting is necessary, and also space and maintenance requirements should be very modest. Well, just something which already Professor Mugazi mentioned, and other people today. Comfort properties consist of sensory properties, psychological component, sensory or tactile properties, fabric hand and handle, and last but not least, also thermo-physiological properties. So also in the presentation of Dr. Lee, the complexity of comfort was very well explained. And let me just shortly describe some simple method. Everybody knows cantilever Pierce method for determination of bending stiffness, which is an example of friendly method. Softometer is a new instrument manufactured by the Wolf company in Germany, and such an instrument, I don't have the picture, automates the bending of the fabric, and the deformation force is measured. But there is another instrument made in Czech Republic several years ago, and these instruments work similarly. So this is the clamp where the fabric is fixed, the strip of fabric 5 centimeter width, and that clamp is rotating till it touches the sensor, and that sensor measures the in fact bending force. So this is the Czech TH5 instrument for bending stiffness evaluation. Let me now explain shortly, let's say, new method which we have developed in Liberec, in our university. Everybody knows that the classical Q6 method for the drain measurement is really very widely used and simply simple in understanding, and really many companies and universities are using this method, but still this method is too complex for factory labs. Do you know a medium company, medium textile mill, where that Q6 drain drape needle is used, I don't know. Simply it's still too big, too large, too complex, too costly. That's why we have developed a very, I can even say, very primitive method, which depends in bending of a square fabric 2420 over sharp edge, sharp corner. I don't have the fabric here, we don't have time enough, but imagine that you have such 2420 piece of fabric, the best woven fabric, you bend it over sharp corner, and that sharp corner makes a linear, very, very direct edge, and the angle between horizontal plane and this edge we measure just by means of simple rule, and we have found that cosinus of that angle, how much? Cosinus of that angle is directly proportional to Q6 draping method, and the cost of the instrument is zero. So we are now asking many institutes and universities, please try to copy it and send us your results. Maybe we will make a new standard, because such a method can be easily used in shops. In every shop you can measure drape angle. Even in case you use that configuration, so if we measure just the corner of the fabric, no cutting, no sample cutting is necessary. We will measure just on existing bale of roll of fabric. So I suggest that somebody can try it. I have to continue. This is the principle. You will find some equations in the paper, on the CD, and I must go on because time is running. 3/10, another instrument developed in Liberec. We measure, by these versatile instruments, we measure yarn friction, fabric friction, yarn tension, internal hardness, and we also measure what else? Yes. The principle is based on the measurement of small torque momentum. We have developed a special sensor which is sensitive to very low torque momentum values, and the signal is processed electronically. This is the mechanical version of the instrument, 3/10. The instrument was commercialized and now is used in 3 universities. This is the description of the friction disk measurement. Such an instrument can be, it is a pocket instrument. You can put it in the pocket and take it with everywhere. Okay, now let's go on. Not everybody knows that in Sierra, South Africa, a special instrument was developed for the measurement of extension, and this instrument works with a full piece of fabric. No cutting, no sample cutting. They put the clamps in the middle of fabric. They extend the fabric. They get very reasonable results. They don't destroy the fabric. They work just really with existing no cutting simply. The Professor Hunter and also Dr. Han, who was here before, is co-author of that instrument. Ring measurement. This is a method which was probably developed in Egypt or maybe in some Arabic country. I wrote in the paper, you can find that the principle is given by pulling a fabric through a short hollow cylinder, and the complex force is measured as a function of the distance. It is believed that such a method was developed in ancient time when the Arabic bride should convince the groom that her costume, wedding costume, is made of very fine silk. And in this case, the costume, the robe, or simply the wedding robe, should pass completely through the ring, through the marriage ring, wedding ring. In this case, the bride or the lady was rich enough to be married or something like that. Anyway, the method was completed and let's say evaluated in Alexandria University. We don't have time enough to speak more about that method. Hes-Parallel comes from the United States, and it also measures the complex effect of several mechanical parameters. Let's go on. Kawabata instruments, it's here just to complete the set, but everybody knows the system. The last version is automatic. Just two systems are necessary, two separate fabric samples are required. And there is a new instrument developed by George Professor Stilios from Scottish College. This instrument measures 6 parameters in one sequence. So he made just one sample, 20 he puts the sample in the instrument, and the whole sample is automatically measured. 6 independent mechanical parameters are determined, and the final charts, snake charts, are evaluated by automatic procedure. We have the Alambeta instrument, which measures 2 independent thermal properties and 1 mechanical properties in one step. The measurement takes just 3-5 minutes according to the thickness. The instrument measures one special parameter, which is warm-cool feeling expressed in terms of thermal absorptivity. This is the new parameter which is not depending on temperature gradient between the fabric and the hand. This is the Iberit, this is the real fabric parameter, and today we have about 30 instruments we have commercialized where this principle is used. Statistic calculations and PC printing of tables and PC, let's say, evaluation is natural. Well, this instrument later was used for some improvement in Hong Kong Polytechnic. Maybe please look at that warm-cool feeling definition. This is something which not everybody knows. Just a half minute warm-cool feeling we get when we touch shortly any fabric. I mean, that jacket, that body, that wood, anything which is different. And the feeling we get within 2 seconds, first 2 seconds, is not thermal insulation, it is really warm feeling. This parameter is extremely important when shopping, when making shops, because this is the first impression we get. We get friction, compressibility, and yes, okay. Thermo is a Kawabata instrument which also measures warm-cool feeling, but the principle is different. And this is the full description of Alambeta. I must skip it. Hopefully, who is interested can find it. The full description of the instrument can find in the CD. This is the measuring head, heated to 32 degrees, and that instrument simulates our skin. These are the components of the instrument. Everything is described in the book. These are typical parameters of thermal absorptivity, which extends from 20 to 1000. By means of this instrument, we can also measure the integrated factor, wetting and wicking. Independent parameters, 2 thermal parameters, and also compressibility, fabric friction, bending stiffness, and drape resistance. The measurement takes just 3 to 5 minutes, and the prototype was exposed at the last Hong Kong conference, ATC 6, last year. Details are also described in the book. Conclusions are the following. I Unfortunately, I think that some of the standard methods, which are now as a European rule or maybe world rule, perhaps such standards, they are subjected to certain strategic interests of large testing companies. If I have a good instrument, I wouldn't get rid easily of such instrument, but world is changing, and I think that also standards should change. And this survey should serve as an indication, let's say, to initiate, let's say, new thinking in terms of new standards which are more close to the client, which are more close to market. Thank you for your attention.
Are there any questions, very briefly? Could you use the microphone?
Yes. Professor Hes, how do you distinguish between your three-tons and the hand force apparatus? Both seems to do the same thing. If one in hand force apparatus, you squeeze the fabric to the hole, and in your three-tons friction tester, you just tend to rub on that slot. How do you differentiate these two test apparatus?
You mean how 3/10 measures the friction?
Yes, and to me, what I comprehend from your brief discussion is that both are similar in describing the hand. One describes it as a friction, another describes it as a comprehensive hand force. How do you discriminate these two apparatus?
No, sorry, the 3/10 measures just friction on the principle of torque, which you know from Clemson 2 years ago, of course. This is the same instrument, but that instrument can be also used for hardness of bobbins. We apply a needle, and that needle is inserted into the bobbin, and we measure the torque. So we measure the internal hardness of bobbin, interesting for cotton people. And we also measure, by means of this instrument, the yarn tension, using also, again, the torque momentum measurement. Okay?
One more question.
I would like just to have a small comment on the ring distance.
Please.
This method is mainly used for testing wool, fabric,
Good.
especially extra fine type of wool.
Great, I didn't know
Merino,
that.
Australian, mainly. And it gives an indication of the softness, bulkiness, and high grade of wool. Because the more soft, the more bulky, the more soft handle, it will pass easily through the ring. And usually it is done even in shops by scarves or shawls, and you put it through the ring, and this especially for wool, mainly, to differentiate between different types of wool, especially superfine type.
Great. I will complete the paper. Thank you very much.
Okay. On behalf of all of the speakers this afternoon on this session, I'm sure that like me you would like to thank them for all the hard work and for a wide range of very interesting and stimulating papers this afternoon.